Hello, welcome to Sawmill's webinar, Why Your Observability Bill Keeps Climbing and How to Stop It. I'm Winston Bowden. I'm the VP of Marketing here at Sawmills. You're not going to hear a lot from me today. I'm going to be here to manage the Q&A, but I did want to go over just a couple of quick housekeeping notes before we jump into the content. As you know, this session is being recorded. We'll be sending this out after the completion of the event. We will have time for Q&A, so please feel free to use the Q&A panel here in Zoom. I'll be keeping an eye on it throughout the session. If you do have any technical issues, you can try dropping out of the webinar and dropping back. And lastly, please do feel free to engage in the chat. Just make sure to select everyone when you post so that others can see your message. And with that, I'm going to turn it over to our CEO, Ronit. Ronit, take it away.
Thanks, Winston. A little bit about myself. My name is Ronit, and I'm the co-founder and CEO of Sawmills. Before starting Sawmills, I was GM at a company called Tricentis. Before that, I was 3 times COO of companies that were acquired, one by Splunk, one by CloudBees, and one by Tricentis. Started my career in the observability space and spent all my career with startups that develop technical products for technical people. With me on the webinar is my co-founder, Erez Rozovsky. He's our Chief Product Officer. Before starting Sawmills, he was in charge at CloudBees of the next-gen CI/CD products. Before that, he was co-founder and CEO of a company that did developed Feature Flag as a service that was acquired by CloudBees. He's a technical guy that started his career at Intel as a DevOps engineer. We have a third co-founder who's not with us today, our CTO, who's VP of engineering at New Relic in charge of their AI ops. A little bit about Sawmills. We are the first smart telemetry management platform. We continuously analyze your telemetry data in stream. We understand your data, and then we come with recommendations as to what you can do with the data, how you can improve the data, both from a cost perspective as well as from a quality perspective. We don't stop there. We also, at that point, allow you to take an action based on that recommendation with a click of a button. So from identification of potential cost savings actions to actually taking the actions. Next. A little bit more about Sawmills. As you know, we are a startup company. We were founded a year ago in April of 2024. We were in stealth, working together with our customers, building a product for the first year. We came out of stealth in February, so a couple of months ago. And if you want to read more about Sawmills, you can find it in these media outlets, in these articles. So why observability cost becomes such a big issue? If you look at the root cause of that, you can find it in this slide. That is part of the root cause of the problem. Telemetry data that is sent to observability solution is growing over 35% year over year. All observability solutions, whether they're cloud providers or on-prem, are directly impacted. Their cost is directly impacted by the amount of telemetry data that is sent to them. This is just one example of an extreme case. I'm sure we all heard about it. The Datadog bill was $65 million for one public company. They actually mentioned it in their annual reports. But if you think about cost, this goes beyond just the increasing cost. You have an incredibly increasing cost. You don't know what is the root cause. You don't know which is the main culprit. You have lack of governance, which the result of that lack of governance is unpredictable spikes in your bill, which is really hard to predict ahead of time, as mentioned. But if you go beyond it, the amount of telemetry data that is sent today makes root cause analysis also more difficult. And if that's not enough, in reality, and this is something that we haven't only seen at our customers, but we've also heard time and again, 80% of telemetry data that is sent today to your observability solutions is not queried and not used. So a lot of junk is going today into your observability solution, and you're paying for that. Next. So we all know that typically the owner of the observability solution is the DevOps. They're the guys who own it. However, these are not the guys that create the challenge. The majority of the challenge, the majority of the telemetry data is created today by developers, in the applications that they write. So the DevOps people are the ones who feel the heat when it comes to cost and when it comes to the quality of the telemetry data, but they're not the ones who can fix it. In order to fix it today, they need to go back to the developers, work with them in order to fix the challenges in the telemetry data. However, engineers are typically busy with writing new features. They're not too interested in making the changes, the required changes. And sometimes they even don't know what changes they need to make, which just makes the problem even bigger. So what do you do? What can you do about it? Erez, to you.
Yeah, so hi everybody, Erez here. I'm gonna walk you through of a few things you could do to optimize your telemetry data cost. And we're gonna talk both about the data issues, but things also about the data. And to start, I want to take you through kind of the six measurement or six things that usually affects your telemetry data or observability cost. So, and each vendor has their own permutation or their own set of measurements that they charge by. But these are essentially the big items that you should look for. And when we think about optimizing telemetry or observability cost, you need to think about these metrics, right? So first and foremost is the volume-based pricing. Basically, how much gigabytes are you sending ingested, or how many gigabytes are you actually indexing, meaning saving? The second piece is the event-based pricing, meaning the number of messages you send, not the volume, but the number of messages. And again, there's a difference between ingested and indexed, and we're going to talk about this in a second. Retention cost, that's essentially for how long are you saving the data. The shorter period of time, the better. If you save data for a long time, that costs more. Some observability vendors recently have changed their pricing to be focused on compute or resource-based pricing, meaning how much compute are you actually using. And the approach over here was to say, I'm not going to charge you by volume or by event-based. I'm going to actually look at the actual usage of the data. This is nice in theory, but in many cases, you would see that this is connected to the query. So if you query specific data, you pay for that data. And that makes a ton of sense. But in reality, a lot of engineers usually query things with asterisks, either on the service name or in general. And so then compute becomes very close connected to volume because you're looking at through the entire data set, right? The last piece to remember around the data is the data cardinality, meaning how different is each message from another. And when you speak about high cardinality, you speak about things like session ID, user ID, UUID, things that keep on changing. The higher cardinality, usually the more you pay. This has direct cost effect on the indexing price, but also the volume price. And the last thing I want to talk about is the committed versus the on-demand charges, right? So usually when you have a contract with an observability vendor, there is an agreed committed amount, either volume or event-based or compute. But then if you go over this, usually there's an on-demand price, and that's oftenly overlooked. But then if you cross that committed amount, you actually pay the on-demand price, which is very costly. And I'm focusing on this, we are focusing on this deck or in this webinar on logs. There's a whole lot of set of problems around metrics and a different set of problems for traces. We'll focus on logs because that's usually where the biggest waste happens. So these are the metrics that we're going to look at when we think about optimizing cost. And I'm going to take you through a few common data issue now that affects cardinality, volume, indexed, and in many cases compute. And we're going to see how to optimize these data issues to prevent that. Okay, so let's look at the first data issue, and that's kind of the most common one, the data junk that nobody needs, right? This is essentially a large group of items. There's a few examples over here. We have debug logs in productions. We have access log of accessing static content. We have verbose logs or info logs. There's a bunch of logs that nobody needs. I'm sure you've seen them around, lingering in your data set, right? So what we want to do with the junk is basically filter it out. And the way to do this is, again, you need to find the issue, search for the junk, and you guys should know what is junk for you, and then try to make sense out of it. Meaning, you need to make sure if it affects your observability cost. So you need to measure it by volume and message count. And again, that has direct correlation to also compute if that's the pricing that your observability vendor charges by. What you want to do is filter or sample those at the edge. And I'm going to say that filtering and sampling at the edge because that means a lot. And we're going to talk about this. But when I say at the edge, meaning it's before you send this to the observability vendor, at the log shippers. And that could be the Open Telemetry collector, that could be FluentBit, FileBit, or Vector. And I've included an example. This is the Open Telemetry collector example. Open Telemetry collector, again, it's a log shipper, widely used, probably the most widely used, or at least one of the highest widely used. And over here, we're filtering debug logs that are entering, that you're sending. This is a simple processor or transformation that filters these logs out. Easy to do. The next data issue is, and this is probably the second most common issue that we've seen, is the duplicate patterns, right? Again, this comes in all various forms and sizes, but in many cases, I've included the most common things that we've seen: authentication failures, connection issues, resource unavailability. Even the best teams with the highest hygiene around telemetry data would suffer from this because at one point the system behaves in a particular way, there's an error, and that error or warning or message just repeats, in some cases, millions of times in a very short time span. And again, to solve this, and this is going to be a repeated pattern, you need to find the issue, right? You need to find the pattern that repeats the most by volume and message count. And then you have two options, right? One is to sample, which is the more crude solution because it doesn't save any of the data. You sample 1%, 5%, and you don't really know how many times that really appeared, and you don't save some of the other data around the repeating message. Or the better approach is to duplicate, to deduplicate or aggregate. And again, both of these should be done at the edge. So I'm going to show you an example of an aggregation we've done. You can see on the left side, we have a request with an error code or status code, and then the latency numbers in milliseconds. And you can see on the right side, how does that look aggregated, right? So we reduce the volume significantly and the message count. If we zoom in again, we see that not only that we aggregate and we see how many times a specific message with a specific error code repeated, we actually, the aggregation processor actually created an average, minimum, and maximum for the latency. So it's not only reducing the volume and the message count, but we actually improve the data quality because we have more information. And one thing to mention around aggregation, this is probably one of the most powerful tools that you can use to both lower ingested volume, meaning volume gigabytes, and also message count. And keep in mind that these together have a direct implication on compute-based pricing models. Again, less data, less to search for, or less to search in. Okay, we have a few more problems to talk about. The third-party logs, right? And that could be services that are open source, that could be libraries, frameworks. Essentially, these are logs that your dev team did not add, right? Nobody wrote these logs in your company, right? These are services or utilities that somebody installed. They came pre-configured with some default configuration, and now you're seeing all these logs in your system. Nobody knows if it's meaningful or not, and nobody wants to remove this because they might be meaningful, right? So again, a few examples over here, DNS query results, CI/CD, container orchestration. There's many, many more. And this is a common pattern that we see. Again, what you want to do, find the issues. I repeat this because we automate a lot of the finding, and we'll see this in the demo. But you need to find the issues, understand that it's meaningful, and then you have two options. Configure the service, and most of these services or utilities have a way to configure the verbosity of the logs, or again, filtering at the edge on one of those log shippers that I've outlined before. Again, a quick example, this is a processor in the OpenTelemetry collector that actually filters out Argo CD logs that have severity that is low. Or info or warning, right? Anything above that is going to be still get reported. All the rest are going to get filtered out. Okay. Redundant metadata attributes. Okay, so this is a very interesting item over here. As you guys know, each log line usually has a bunch of metadata around it. And these metadata comes from the cluster, comes from the agent that is sending the data, and from various utilities that you use. And the important thing to keep in mind over here is that these attributes, the metadata attributes, are attached to every log line. So this data repeats for every log line, right? And that creates a lot of bloat and basically increase the volume that you're sending, the ingested cost that you're sending, right? And if you look at this, in many cases, you will find, and we've seen this over and over and over, redundant, duplicate, low quality, unnecessary, high cardinality attributes that you can remove, right? Keep in mind, again, these are repeated for every single message. And so if I look at this again, and we think about how to solve this, basically what you want to do is standardize that list. You want to remove the duplicate. You want to remove the redundancy. You want to remove the high cardinality fields. Basically any field that you could see that has a UUID or a numerical value that keeps on changing. I've outlined a few things that are redundant over here, either because they're duplicate or because they're not necessary. Just if we look at the last two lines over here, file name log dir and file system log file. Again, who needs this, right? This is the file name of the log line. This is the folder where the log line exists. And again, cloud native environments, nobody cares about this. These should be removed. And so, again, in this example, I'm using the OpenTelemetry collector configuration. This can be done with other log shippers, but this is a good example. I'm basically using the attribute processor, and I'm dropping these fields, right? So there's probably around 30 attributes over here. At least 10 of those, which is 30%, can be removed, and you're saving a lot of bloat on the ingested volume. Super important. A lot of low-hanging fruit over here. Last example I'm going to talk about, and these are the common data issues. There's definitely more, but these are the things that we see the most. And this is a funny one. Some logs should not be logs, right? So logs are being misused in many cases. A lot of things are reported as logs that should not be logs. Usually, the way to identify that is low information density, low cardinality, with some numerical value that keeps on changing. Very useful in a trend line or in a metric, but not useful as a single point in time. And again, a few examples over here: queue depth, how many messages were received or sent, what's the time it took a request. And again, these things tend to bloat your observability, both from message count and from volume count. And so if you look at how to solve this, find the issues that are more meaningful. Again, the repeated pattern, and then transform these logs into metrics at the edge. So I have an example over here. This is again the OpenTelemetry collector. This is a processor, actually a few processors that transform a health check log line into a metric, right? This is a more complicated transformation, actually a few transformation, but definitely doable and can actually create a metric out of these logs line. And just to bear in mind, a metric is a fraction of the cost, both in terms of volume, but also has usually a different pricing model, right? So you want to move these things into a metric. They're not helping you as a log line, and they cost you way less as a metric. Okay, so we've talked up to now about a few data issues. Obviously, there's more, but data issues have a core correlation to your observability bloat. And if you fix that, you can definitely optimize your observability cost. Some things are above the data, which is more of the setup of your observability solution. And I'm going to talk about the few issues that are the most meaningful. So first and foremost, I want to talk about ingestion cost and how they add up. And so there's something to talk about over here. Some vendors charge both by the volume that you're sending them, the ingested cost, but also by the indexing cost, meaning the data that you're actually saving. And so in many cases, companies tend to filter out from the indexes, from the data that they're saving for longer periods of time. They tend to filter out a lot of things, but they're still paying for the ingested cost, meaning the volume that they're sending. So basically, they're paying a lot of money in some cases for data that they filter out almost completely and they don't use at all, right? And we've seen cases where ingested cost went up hundreds of thousands of dollars a year, and this is data that nobody is using. This is data that is explicitly filtered out by the company, right? Again, the easy solution over here is to move these filtering to the edge. Again, I'm going to continue that pattern, right? This is your data. You want to control it. You want to own it. You want to manipulate it before you send it. So again, you want to filter that data out at the edge, and that could significantly reduce your ingestion cost. The second piece I want to talk about, which is above the data, is retention, right? So essentially, the longer you save the data, the more you pay. Obvious, you can configure this on each observability vendor. How long do you want to keep the data? And you can define which data you want to keep for which period of time. The general guideline is to say that short-term retention is for the raw data. And then you retain for 7 days or 14 days the high severity logs that usually mean more. Things that you want to keep for longer than 14 days, 30 days, 90 days, security, compliance, those should not be kept on your observability vendor side and should usually be kept on an object storage solution like an S3 bucket or GCS or Azure Blob. Again, these, if you try to save those on the observability sides, cost is going to spike. Okay. So we've covered a lot of the issues and how to solve this, both from a data perspective, but also from a setup perspective. And yes, you can optimize your telemetry data manually. But here's the question. Should you? Should you do this work manually? And I want to make the claim, and I'll show you in a second why you shouldn't, that it's super hard to do this manually. And if you've done this before, you've experienced a lot of these pains, right? It's very hard. It's very hard to find these issues. Telemetry data is repetitive, changing, messy, and complex. It's very hard for humans to find these issues in real time, right? Even if you find these issues in real time and you went through the effort, the data is changing on you super, super fast. So, you know, you find the issues, you fix the issues, and now you have new issues, and the old issues are gone. And so the filtering becomes stale very, very quickly. And then you're essentially spending your time and your engineering time tweaking issues that keep on changing and keep on arising, right? So I want to make the claim that although doable, you should not do this in the old-fashioned manual way. You should have a platform that uses machine learning AI that does that for you, and that's what I'm gonna show you now. So introducing Sawmills. Again, we need to cover this in the beginning, but I'm just gonna repeat some of the core highlights over here. At the core, we save you money, right? We could cut ingestion cost up to 90% with our capabilities. And then we allow you to basically with one click fix issues in real time without having this long cycle of doing this. You could stop the chase between engineering and the platform team, where basically the platform team is chasing engineering to change things. You could either enable your developers or do this yourself. It's very dynamic, it's very quick. You can eliminate surprises, gain visibility in real time to what's actually happening with your telemetry data, and you can enforce budgets. I'm going to show you this in the demo. Improve the data quality, right? So not only that you're reducing costs, but you're improving the data quality. You don't have to sift through a large volume of data to find what you needed. You could standardize structures and the attributes so that you don't have these duplications and inconsistencies, and you could enforce governance. You could define policies that essentially prevent or help the teams have the right data at the right time, at the right place. Okay, so I think without further ado, I'm going to jump to the demo, and let me just switch the screens over here to a demo screen. And okay, so I'm going to take you through a quick demo of our platform, and I'm going to start actually with the highest level over here, which is these insights that we kept on mentioning, the one-click solution. So, right, so this is what we call the Data Explorer. Obviously, it's divided to logs, metrics, and traces. We're currently in the log session or tab, and we have analytics, right? High-level analytics for the past 30 days. We're seeing data that was sent to Datadog. We're seeing the volume, we're seeing the message count, we're seeing how many data sources that we send, and we're also seeing the attributes, right? The metadata attributes that repeat. We see that we have 24 attributes, and actually we can actually control this. We have an allow and deny list, and we can actually standardize this. But what I want to show you for now is the actual insights over here. So again, we have a table over here that shows all the data sources, how much volume that they've generated, what's the message count, if there's any action that was taken for each of these data sources, and then is there any insights for these data sources that you could take an action on. So again, as an example, I'm going to look at the notification service, and if I click on this, I can actually see the insights for this particular service, right? So we have these two insights over here. One of them is that we have a pattern. This is the pattern. And if you look at this closely, you will see that, again, like very common, there is a request to an endpoint with a status code and the response time in milliseconds. Again, we've mentioned this before. This is a classic data issue. This should not be a log line. This should be a metric, right? If you actually transform this into a metric, you're going to save 80% on the volume, right? From 5.4 gigabytes to 1 gigabyte. And the nice thing is that we don't just find the issue for you and tell you the impact and recommend how to solve this. With one click, you can actually create a transformation that turns this into a metric. You don't have to worry about YAML files and deploying configurations to all kinds of agents. We do that for you, right? So if you apply this now, you are actually going to add this transformation to the pipeline, and this data is going to be transformed. There's another insight over here of duplicate log lines. Again, a pattern that repeats. If you aggregate it, you're going to save 24% of the volume of data that is being sent. This is actually a message count. So you're going to save 24% on the message count. We also show you per service the patterns that repeats and how much are they from the total volume. And again, you have the standard processing that you could take, sample, filter, aggregate when relevant. And you could also see pair the data source which actions were taken. So in this example, there's a transformation that masks sensitive data. There's another filter that removes verbose logging. And again, you could turn those on and off very quickly. The whole point is adding these dynamic capabilities to your telemetry data. And so not only having you have control, you could turn things on and off very quickly, right? So again, this is for logs. We have the same idea for metrics, right? We haven't covered metrics at all, but again, our solution is a platform across all telemetry data types. If you look at metrics, this is a metrics catalog. Overall, how many metrics do I see in the system? How many time series? How many labels? What's the message count per label? What's the cardinality? You can see each metric and how many time series and how many labels. Soon enough, we're going to also show you if this metric is being used somewhere in a dashboard, in an alert. And then again, you have the insights, right? I'm not going to stay long over here because we haven't talked about metrics at all, but this is part of the platform. Two other things I want to show in this demo. One of them is the concept of a policy. So we talked about governance and adding guardrails, right? We've added a policy for duplicate log lines. And essentially, we want to catch those bursts of duplicate logs that repeat many, many times. And we want to save that volume of data that is being sent, both from a message count and from a volume perspective. This is a policy that is looking at a window of 1 minute and is actually aggregating similar logs. In this example, we filter out, we just do this for info and warning log. And if the message repeats more than 10 times, this is going to be aggregated. There's a nice audit log over here. You can see when this policy has taken an action and on what. And this, again, I've mentioned this in the past, this is one of the most powerful tools you could use. Very strong policy. There's other policies like masking PII or other sensitive data that you could use. And again, guardrails, governance, you could control the data. The last thing I'm going to talk about is the concept of quotas or budgets. In many cases, teams would want to limit, or centralized teams would want to limit how much data can a specific team generate and resource allocate telemetry data. So again, you could create teams based on various attributes in the data. If I look at the core platform system team, basically they're defined based on a service that contains the word platform in it. There's a policy in place over here at 60% of the threshold. We're not going to do anything. They were giving 1,500 gigabyte of daily log data. And in 80%, we're going to send an email, and at 100%, we're going to start dropping the data. So if the user reaches 1,500 gigabytes of daily data, above it, the system would start dropping their data. Obviously, very aggressive, but it's a possibility that you guys can take. So I think I'm going to stop over here now and open this up for questions.
Okay, thanks, Erez. So a couple of questions, and I think you covered this, but to be sure, can we set different telemetry policies per team or per environment? And I think you just covered a lot of that in the last stage of the demo.
Yeah, 100%, Winston. You're 100% right. Yes, and yes, and yes. We allow you to set filters, policies based on any attribute in your telemetry data. So it can be service name, it can be environment, any attribute that exists in your telemetry data. You can create conditions by it and decide what to do based on that data.
Got it. Thank you. And then this is from another one of our attendees. How is this different than using something like Cribble or the cardinality management that's actually built into observability tools?
That's a great question. There's two questions over here, Cribbles and then the cardinality interface in some, I think Grafana has a nice interface over there. So Cribble is definitely in that space. It's definitely a telemetry pipeline. I think the main difference is that Cribble is very focused on getting access to the data and then configure things manually. I think we take pride in the fact that we find these issues. I think that's a core problem over here, finding these issues and then also recommending how to transform the data in a cost-effective way that is doing less damage or not taking away from the data, but still condenses the data. And I think, on the Cribble side, you have to do everything very manual. The second part is some observability vendors, and I think I've mentioned Grafana, I think, have a cardinality dashboard more geared toward metrics, but definitely in the space. Very similar. I think they see some of the same problems that we're seeing. I think our approach to this is to say we're in stream, so we deal with the data before you send this. We are not replacing the observability vendor. We sit before the observability vendor on an agent that is installed on the customer side or on your side, and the data passes through the agent, and everything that we do happens in stream. So you don't send the data and react after. You see the data as it passes through and then decide what to do with it.
And I think this is related to what you just discussed. But another question is, what happens to that data, the data that is dropped and filtered out?
Yeah, it's a great question. So there's a couple of options. The most basic one is just drop it, don't do anything with it, so it's lost forever. The other option is to route data that you decide that you don't need an object storage. That we've seen that happen many, many times. Essentially, teams would create a pipeline that sends either all the raw data to like an S3 bucket, and then all the filtering, all the processing, all the complicated stuff happen before the vendor. So before you send to Splunk, Datadog, New Relic, etc. So then you have the raw data somewhere. Usually you would want to save those in a more structured file format than just raw data. So like a Parquet format that is more cost effective. And yes, we've seen that.
Awesome. I think that is all the questions that we have right now in the Q&A. I would encourage everyone to check out sawmills.ai. We have a lot of content on our website that discusses some of the points that Erez and Ronit made today. If there are no other questions, I think we can close things out. As we mentioned, we will be sending this out via email, so don't worry if we miss something. If you missed something, didn't take notes, we're going to send this to you in your email. And of course, you can reach out to us on email. Erez, I think your email is simply erez@sawmills.ai and ronit@sawmills.ai. And we'd be happy to take you through the product one-on-one.
Thanks, everybody.
Thank you.
Thank you, Erez. Thank you, Ronit.
Bye, guys.